Okay, so review again, vocabulary. Parallel lines, here's the symbol. Two lines are parallel when their slopes are the same. Check, we found the same number in our Find Someone activity. Perpendicular lines, here's the symbol for perpendicular. Their slopes are opposite reciprocals. To help ourselves remember what that means, you're going to flip the fraction and you're going to flip the sign. Flip and flip. Now there are really special cases of lines that you may see on your graphs. They're called horizontal and vertical lines, and we went over them last time, but just as a reminder, let's draw some over here. They don't have to be perfect, but on a coordinate grid, I want you to draw a horizontal line, and I want you to draw a perpendicular line. Because these lines are always specifically parallel and perpendicular to parts of your graph itself. My horizontal line is the green one. Which axis, X or Y, is the green line parallel to? The x-axis. So the green line, horizontal lines are parallel to the x-axis. They go the same direction. The purple line is parallel to which axis? The y-axis. If I switch my question and I say the green line is perpendicular to which axis, which one is it perpendicular to? Why? Because it crosses it at a right angle. What is perpendicular to this vertical line? The x-axis. Very good, because it meets at a right angle. Now, I do want to explain why that happens, because this is really going to be something that comes back later on today. When we're talking about straight up numbers, okay, just regular straight up numbers, the number 0 can be written as a number 0 over anything. Any number whatsoever, n for number. So this is 0 over a number. That means you're on track. That's the number 0. What happens if I flip that? If I use the reciprocal value, which means I'm going to have a number divided by 0. Are you allowed to do that? No, it literally says the word no right there. You are not allowed to divide by 0. That is why we have a number called undefined. We actually don't know, mathematicians in general, people, we don't know what happens when you divide by 0 because it doesn't make any sense. You take all these things, you put them into 0 groups. You'd be like, what do I do with the things? It doesn't make sense. It's undefined. This is why those two numbers are 0 slope, horizontal lines, and our vertical slope, undefined lines, are opposite reciprocals. They're perpendicular to each other because we can flip that number over and make it negative, and it's a no-no, or you're on track. Okay? That's just a property of numbers that we could hang on to for later. What we're going to be doing today is working on writing equations that are parallel and perpendicular to different lines. Again, this is a skill from Algebra 1, but in Algebra 1 you probably used pieces of technology to do this, Desmos. We're going to do it by hand today. So we need to know a few things. We need to know first the different parts of what's called slope-intercept form. Don't overthink this. What is the m representing in slope-intercept form? Let me use a different color. The slope. M is the slope. Check. What is the b representing? The y-intercept. That's why it's called slope-intercept form, because it shows you the slope and the y-intercept, or the beginning value. The x and the y are going to stay in the equation. They represent all of the other variables along our graph, all of the other locations, x and y. So the first step today is making sure we can identify correct slopes and then decide what's parallel perpendicular. So in example 1, it says find the slope of the line that is parallel to the line given. Okay, don't overthink this. What's the slope of equation A? -4. All right, circle the slope. We're going to be circling our slopes today. Now, if I want to know the parallel slope to this, do you do anything to that slope value? Or do you tell me the exact same number? Exact same number, because we want the parallel slope. So we're going to say, all right, the slope that is parallel to that is going to be -4. Notice the symbols I'm using. I'm using an M with a little bitty subscript of the parallel to show that I'm talking about the parallel slope. Yes? Okay, let's go to part B. Can you immediately tell me what the slope of that line is? No, because it's not in a form that we've been using that is called slope-intercept or point-slope. So we need to solve for y. I taught you 2 steps last time to solve for y. The first one is to move. If you take that -5 and move it to the other side, what does it become? Positive. And after we move, does anyone remember the second step? Starts with a D. Divide, because we want the y to be all the way by itself. So we're going to divide every single number in this problem by 2. We would end up with y equal to 1x plus 5 divided by 2, which is 2.5. Okay, now, what is the slope showing? 1. If we want the parallel slope to that, what number am I also going to use? 1. So my parallel slope is the number 1. It's m with a little bitty subscript of parallel to show that we're talking about the parallel slope. I mean, it's the same number. Ooh, challenge question, part C. What kind of line is it when it just says y equal to some number with no x at all? It's a straight flat line. So Joseph had his hand like this. So this is my horizontal line. What kind of slopes does a horizontal line have? 0. So if the slope of this guy is 0, what is my parallel slope? Also 0, yeah. Because we just want to use the same number. So we see how our very first step in the problems we're going to do today is identifying the slope we want to use. If it says parallel, you use the exact same number. Check, done. We're going to go to example 2, but we're going to skip to question B first. This time when we're doing these problems, it asks me for the perpendicular slope. Sorry, wrong color. Perpendicular slope. If we want the slope that's perpendicular to it, for part B, what is the slope of that line right now? 2/3. All right, we want the perpendicular slope. So am I going to use 2/3? No, what am I going to do to that number to make it perpendicular? Flip and change the sign. Very good. So we have to pay attention to what word we're asking for, whether we're asking for parallel or for perpendicular. And we need to make sure if it says perpendicular, we actually flip and flip. I'm going to go to number C next. I'm saving part A for last for a reason. Okay, for this one, can you tell me what the slope is right away? No, but there's 2 steps to be able to do it. What's that first step? Move 14. When I move it over there, does it become positive or negative? Positive. So we have 9y equal to 15x plus 14 because I moved the 14 over. That was my first step. Brian, what's my last step? Fabulous. Yes, we're going to divide by 9. And so we have y equal to, 15 divided by 9. I think that one might reduce. Can somebody put that fancy fraction in their calculator and see what it reduces to? 5/3, right? And then 14 divided by 9, I'll give it to you right now. It doesn't reduce. Okay, what is the slope of this line currently? 5/3. If we want the perpendicular slope, what slope are we going to use? Almost. Negative 3/5. There you go. We have to flip and flip. So we not only flip the fraction, we flip the sign. Okay, I skipped answer A or question A on purpose because it's a little bit tricky. Kind of like number C on the first example. For letter A, it just says x equal to some number. What kind of lines are x equal to some number? Like straight up and down, yeah? That's a vertical line. What kind of slopes do vertical lines have? Slope is undefined. Now, we just talked about this earlier. Undefined means that you are dividing by 0. We're going to put the number or the letter n up here. If I want the perpendicular slope to this, to an undefined, that means I want to flip this fraction. What number do I get when I flip that fraction? 0. And if I make it negative, is there such a thing as negative 0? No, so it's just going to be plain 0. So perpendicular, undefined, and 0 are opposites of each other, opposite reciprocals specifically. So if you have a vertical or a horizontal line, you have to use the opposite, 0 or undefined, to find the slope of the other line. Okay, let's pause for a second. On questions 1 or 2, do you have any questions for me? / maybe catch up on writing since I went a little fast on part C. Okay, fabulous. If you look on your notes, what have I already done for you this time? I've done one of the examples for you because I wanted you to have nice, neat handwriting on your paper, and we're going to look at a fully completed example and see what happens each time and what you should be doing. This question says, write an equation in point-slope form and then convert the equation into slope-intercept. So let's see, what did I do very first? What is happening right here? Yeah, I'm labeling my points. So the very first thing you need to do is label your points. That's the first thing I'm doing. That way, this is what we're doing. We're looking at the problem itself and seeing what I did so that you can follow those same steps. After I labeled this, I took all of this information and put it in point-slope form. And let me color code for you. Point-slope form, which is this formula right here. We're going to need this all day. We're going to plug in 3 things. You're going to plug in the slope, which is why the 4 ended up right there. Do we see that? You're also going to plug in your x1 and y1, which is why you have a 1 right here and a 2 right here from these guys. So we're taking 3 things, a point and a slope, and we're plugging it in to the point-slope form of this equation. The regular x and the regular y should stay in your equation. Don't replace those. They stay in your equation. So the second thing I did was fill in the m and the x1 and y1. If you're making a list of things to do for yourself, that's what I did. I plugged my stuff into the formula. Okay, the next thing I did, can anybody tell what happened from this line to this line? What has changed? I noticed those parentheses went away. How could these parentheses go away? Multiply. We're going to distribute the number in the very front. So that's the third step. We're going to distribute. 4 times x is 4x. 4 times -1 is -4. How did I go from this step to this step? I noticed that it originally said y minus 2, and now all of a sudden it says y. How do you get this to go away? Don't we add 2 to both sides? Which will make this cross out. So we do inverse operations to solve for y. And if you don't trust me, in your calculator right now, do -4 plus 2. You should end up with -2. Notice that I did not add the plus 2 to the 4x because these are not like terms. I added it together to the 4, the plain number, the constant. Okay, those are all the steps to write an equation in point-slope form and then convert it to slope-intercept form. I want you to practice these same steps on example 4. So start from the beginning, which means the very first thing you do is label. Then you're going to fill in. Then you're going to distribute and inverse operations. You have 4 steps here. You got this. I want you to try example 4. If I look at this one, and I'm just going to get us started because I think we're either stalled out because we all got to a point that we don't know, or we're waiting for me. This is x1, y1, and then this is my slope. So I have the 3 things that I need to plug in. I'm going to plug in the slope, and I'm going to plug in the points. Here I go. It would be y minus y1 equal to m times x minus x1. Pause. Did we all get that far? Fabulous. Because again, we put our slope where the slope goes, we put our x1 where the x1 goes, and our y1 where the y1 goes. Now, I did actually have a little stretch question in here for you, because when I do my next step, which is distributing, this right side of the equation becomes 1/2 x minus 1. But I can actually simplify the left side. What is minus a minus? Positive. So when I write this down, I actually want to simplify that part to a +3. I know when we did slopes the other day, I did not have you simplify the minus a minus. And that's because your calculator was doing all the work. When the calculator does all the work, you really don't need to simplify. But when our brains are doing the work, like in this kind of problem, we want to simplify the minus a minus so that we don't make an algebra mistake or an arithmetic mistake. Because now that I look like this, that last step is to do inverse operations. Well, what's the inverse of +3? -3. And that might be a mistake that you make if you forget to do minus a minus. This will become y equal to 1/2 x minus 4. So that is my equation that goes through the point 2, -3 and has a slope of 1/2. On to the back we go. We're going to now connect this with what we did last class, because we've been writing equations in point slope and converting to slope intercept in algebra 1. Yeah, cool, whatever. But this is geometry class. How do we make this a little bit more geometry? I'm going to ask you to find the equations of parallel lines and perpendicular lines. Remember, when we do parallel lines, that the slope should be the same. Let's write that note for ourselves. Parallel lines are the same slope. So if we look at the steps I've done in question number 5, to write an equation of a line in slope-intercept form that passes through point P and is parallel to the given line, look at my steps. What did I do first right here that I'm pointing at with my little arrow? It's the first step it was a second ago. What was it? Label. But this time I need to figure out the slope of this given line and make sure I use the right one. Well, when we did this on the front side of this page, we said, all right, well, if we want the parallel slope, we just want to use the same number. So I have that the parallel slope is going to be the same number from one equation to the other, 2/3. That becomes the slope that I plug in to my formula here, along with my coordinate points 3, -2. After that, after you've decided what slope to use, it's exactly like the front page where we did distribution. Notice I simplified my minus a minus here. And then I did inverse operations to solve for y. Are there any questions about this example 5? Because you're going to do example 6. Let's give it a shot. Example 6 is yours. I want you to write the slope or the equation of the line that passes through this coordinate point and is parallel to this line. So figure out what slope you should use and then do the problem just like we did on the front. I'm going to start working it really slowly without talking. So if you're super stuck, you can look at the board, but I don't want to interrupt your thinking. Okay, I had a couple good questions here. So some things I'm seeing. Make sure that when you label your points, you're using the correct points. We don't really care about the 3. That's a part of the y-intercept of the other graph. Cool, great, whatever. I just wanted the slope out of that one. The other thing I'm seeing, and I see this all the time when I taught Algebra 1, we forget that distribution goes to both terms. I'm not drawing these arrows for my health. I highly recommend drawing them because it physically reminds you that you have to multiply both numbers. 6 times x, which is 6x, and 6 times -8, which is -48. So do the arrows. Help yourself out. How do we feel about this one? Okay? Yeah, it's basically like what we did on front. We just had to make sure we were using the correct slope that was perpendicular. Parallel. Let me change my color code on this just before I forget that I wanted to do that so that my notes look the same. All right, my question for you this time, down at the bottom, is not to write the equation of a parallel line, but of a perpendicular line. What kind of slopes do perpendicular lines have? Because they're not the same anymore. What are these ones called? 2 words. Opposite what? Reciprocal. Yeah. Opposite reciprocal. That means it's the ones that we're going to have to flip and flip. So let's look at a fully worked out example so you can see what I want you to do in your next problem. Okay. Number 1, I labeled. It's been the same step 1 the whole time, yes? So I labeled my x1 and my y1, and then I looked for the slope. Can I right now tell you the slope of this line? No, it is not in a form with a slope showing. So I did my 2 steps. I moved the 2x over, it became negative. Then I divided by 3, which means that this equation had a slope of -2/3. I want the perpendicular slope. So did I use the number -2/3? No, I flipped that number over and changed the sign. Now I have the slope that I want to use in my slope-intercept form. Point-slope form. So I have my slope plugged in. I have my coordinate point, -3, -1 plugged in. Has anything really changed about what I did? I still labeled my points, found the slope, and used the correct slope. It just requires more thinking because it's not the exact same number.
So every time you move something, you change the sign, right?
Correct. If you move it from one side of an equal sign to the other, it changes signs.
Okay.
After this, all I did was distribute, just like we did before. You might need a calculator since we're dealing with a fraction, but that's okay. So we had 3 over 2 times x, which is 3 over 2x. 3 over 2 times positive 3, since minus a minus is plus, is positive 9 over 2. We would also make this a positive since minus a minus is a plus. And then my last step is the same, to subtract 1. Again, use a calculator. Don't panic if there's fractions because you have a whole calculator there to give you your answers. So it's the same steps as before, but putting it all together in one problem. I still feel like we need to do number, not 8, what is it, 8 together? So let's all together do number 8. Okay, first things first. What should I do? Label, thank you. So we're going to label this as x1 and y1. The next thing I needed to do was figure out what slope to use. Can you right now tell me the slope to use out of this equation? No, it's not in the form we want. So what are my 2 steps? What's that first step? Thank you, Mr. Williams. We're going to move the x. When I move that x across the equal sign, what does it become?
Positive.
Ooh, it was
Whoa.
positive,
Yeah.
so it becomes a negative. Okay. Brian, you answered this earlier and you did it great, so I'm going to ask you again. What's the next step? So we divide all 3 numbers by 3. Again, don't let this part be the part you're messing up on because it's just arithmetic. This is going to be y equal to negative 1x minus 4. Now that it's written like this, what is the slope of that line? Negative 1. We want the perpendicular slope to that. So the number negative 1, just in case you remember it, is the number negative 1 over 1. If I want the slope that's perpendicular to that, what number am I going to use? Ooh, remember we flip and flip. How do you flip this number over? Positive 1. So we flip the fraction, we change the sign. We're going to use the number 1, which is the same as 1 over 1. There's my perpendicular slope that we're going to use in our equation. From here on out, it's exactly like the problem on the front of the page that we were really good at. So we take the highlighted numbers, the things we've labeled, and we plug it in. This would be y minus negative 2 equal to m, the perpendicular m, times x minus x1. What's the next step? After we fill it all in, what have we always been doing? What's that called with the arrows? We'll subtract later. We distribute. Okay, so we distribute 1 times x and 1 times negative 2. I'm also going to simplify that minus a minus when I write the left side down because I don't love that it's a minus a minus. This is going to be 1x minus 2. And now, Chris, we're going to do the step you wanted. What's that last step? Subtract 2. This would become y equal to 1x minus 4. Now, question for you, because sometimes when you take multiple choice tests, the answer won't look like this. Do y'all remember that the 1 can be invisible? So you can show the 1 or you can let the 1 be invisible. I love to let the 1 be invisible, but if you want to put the 1s there, that's okay too. So today, our main goal is to be able to do problems like the back, to write equations for parallel and write equations for perpendicular lines given sets of information. What we're going to do to practice this today is some error analysis. So we are going to give you a bunch of problems, 10 problems, already completely worked out, but they're all done wrong. Your job is to look through the teacher's work or the student's work and figure out what they did wrong. All of them have made one mistake, and then you're going to fix their mistake. So your classwork / your homework, if you don't finish, is 10 problems of error analysis. If you're like, Miss Quickly, what problems? Go to Google Classroom because they've posted for you today. It's a PDF document for you to look through. That's what we're working on now. Oh, I forgot to turn this off.